Welcome to the channel NextGen Tech Prep. In today's video, we are diving deep into essential questions and comprehensive answers for the Google Professional Cloud Architect certification. Whether you're preparing for an exam or just looking to sharpen your knowledge, you're in the right place. If you find this content valuable, please hit that subscribe button and ring the notification bell so you never miss an update. Now, let's get started.
You are migrating third-party applications from optimized on-premises virtual machines to Google Cloud. You are unsure about the optimum CPU and memory options. The applications have a consistent usage pattern across multiple weeks. You want to optimize resource usage for the lowest cost. What should you do? The options are: Option A, create an instance template with the smallest available machine type, and use an image of the third-party application taken from a current on-premises virtual machine. Create a managed instance group that uses average CPU utilization to auto-scale the number of instances in the group. Modify the average CPU utilization threshold to optimize the number of instances running. Option B, create an App Engine flexible environment, and deploy the third-party application using a Docker file and a custom runtime. Set CPU and memory options similar to your application's current on-premises virtual machine in the app YAML file. And the remaining options are: Option C, create multiple compute engine instances with varying CPU and memory options. Install the Cloud Monitoring Agent, and deploy the third-party application on each of them. Run a load test with high traffic levels on the application, and use the results to determine the optimal settings. Option D, create a compute engine instance with CPU and memory options similar to your application's current on-premises virtual machine. Install the Cloud Monitoring Agent, and deploy the third-party application. Run a load test with normal traffic levels on the application, and follow the right-sizing recommendations in the Cloud Console.
To arrive at the correct answer, we focus on the keywords: unsure about the optimum CPU and memory options, consistent usage pattern, optimize resource usage for the lowest cost.
Review the options on screen. The correct answer is Option D, create a compute engine instance with CPU and memory options similar to your application's current on-premises virtual machine. Install the Cloud Monitoring Agent, and deploy the third-party application. Run a load test with normal traffic levels on the application, and follow the right-sizing recommendations in the Cloud Console.
Why is this correct? D. Deploying a compute engine instance with current on-premises specifications alongside the Cloud Monitoring Agent allows GCP to collect actual telemetry under normal traffic. The Cloud Console then provides accurate right-sizing recommendations to optimize CPU, memory, and cost. Why are the others incorrect? A. Managed Instance Group horizontal autoscaling with small instances is designed for variable web traffic scaling, not for determining the optimal vertical CPU and memory configuration of a single application workload. B. Migrating to App Engine flexible environment requires containerization overhead in custom runtimes, while manually copying static on-premises settings misses GCP's automated right-sizing recommendations. C. Provisioning multiple parallel instances and running high-traffic load tests is unnecessarily expensive, complex, and distorts resource monitoring results compared to actual normal usage patterns.
Your company has a Google Cloud project that uses BigQuery for data warehousing. They have a VPN tunnel between the on-premises environment and Google Cloud that is configured with Cloud VPN. The security team wants to avoid data exfiltration by malicious insiders, compromised code, and accidental oversharing. What should they do? The options are: Option A, configure private Google access for on-premises only. Option B, perform the following tasks. 1. Create a service account. 2. Give the BigQuery job user role and storage reader role to the service account. 3. Remove all other IAM access from the project. Option C, configure VPC service controls and configure private Google access. Option D, configure private Google access.
To arrive at the correct answer, we focus on the keywords BigQuery, Cloud VPN, avoid data exfiltration, malicious insiders, compromised code, and accidental oversharing.
The correct answer is option C. Configure VPC service controls and configure private Google access.
Why is this correct? C. VPC service controls creates a security perimeter around Google Cloud resources like BigQuery to prevent data exfiltration caused by malicious insiders or compromised code. Private Google Access enables secure private connectivity between on-premises environments and Google Cloud services over Cloud VPN. Why are the others incorrect? A. Private Google Access for on-premises enables private connectivity to Google APIs, but it lacks security perimeter capabilities required to prevent data exfiltration. B. Modifying IAM roles limits permissions but cannot prevent data exfiltration by authorized entities or compromised code operating within granted permissions. D. Private Google Access routes internal VM traffic to Google APIs without public IPs, but does not provide security perimeters to block data exfiltration.
You are working at an institution that processes medical data. You are migrating several workloads onto Google Cloud. Company policies require all workloads to run on physically separated hardware, and workloads from different clients must also be separated. You created a sole tenant node group and added a node for each client. You need to deploy the workloads on these dedicated hosts. What should you do? The options are: Option A, add the node group name as a network tag when creating Compute Engine instances in order to host each workload on the correct node group. Option B, add the node name as a network tag when creating Compute Engine instances in order to host each workload on the correct node. Option C, use node affinity labels based on the node group name when creating Compute Engine instances in order to host each workload on the correct node group. Option D, use node affinity labels based on the node name when creating Compute Engine instances in order to host each workload on the correct node.
To arrive at the correct answer, we focus on the keywords physically separated hardware. Workloads from different clients must also be separated. Sole tenant node group, added a node for each client.
The correct answer is option D. Use node affinity labels based on the node name when creating Compute Engine instances in order to host each workload on the correct node.
Why is this correct? D. Node affinity labels allow you to schedule Compute Engine instances onto specific sole tenant nodes. Because a specific node was created for each client, using node affinity labels based on the node name ensures each client's workload runs on its designated host. Why are the others incorrect? A. Network tags are used for firewall configuration and routing, not for scheduling instances on sole tenant nodes. Furthermore, targeting the node group name does not isolate workloads to a specific client node. B. Network tags manage networking policies and firewalls rather than sole tenant VM scheduling. They cannot be used to target specific sole tenant nodes for instance placement. C. Using node affinity based on the node group name distributes instances across any node in the group, failing to guarantee that a client's workload lands on its dedicated client node.
Your company's test suite is a custom C++ application that runs tests throughout each day on Linux virtual machines. The full test suite takes several hours to complete, running on a limited number of on-premises servers reserved for testing. Your company wants to move the testing infrastructure to the cloud, to reduce the amount of time it takes to fully test a change to the system, while changing the tests as little as possible. Which cloud infrastructure should you recommend? The options are: Option A, Google Compute Engine Unmanaged Instance Groups and Network Load Balancer. Option B, Google Compute Engine Managed Instance Groups with Autoscaling. Option C, Google Cloud Dataproc to run Apache Hadoop jobs to process each test. Option D, Google App Engine with Google Stackdriver for logging.
To arrive at the correct answer, we focus on the keywords custom C++ application, reduce the amount of time it takes to fully test, changing the tests as little as possible.
The correct answer is option B. Google Compute Engine Managed Instance Groups with Autoscaling.
Why is this correct? B. Compute engine managed instance groups with autoscaling allow running the existing Linux VM environment for custom C++ tests while dynamically scaling out instances to run tests in parallel, significantly reducing completion time with minimal changes. Why are the others incorrect? A. Unmanaged instance groups do not support autoscaling or automated instance management, making them incapable of dynamically scaling out resources to reduce testing time. C. Cloud Dataproc is optimized for big data frameworks like Hadoop and Spark, which would require refactoring or rewriting the custom C++ testing application. D. App Engine is a serverless/PaaS platform optimized for web apps and APIs, which cannot natively host arbitrary custom C++ test suites on Linux VMs without refactoring.
A lead software engineer tells you that his new application design uses WebSockets and HTTP sessions that are not distributed across the web servers. You want to help him ensure his application will run properly on Google Cloud Platform. What should you do? The options are: Option A, help the engineer to convert his WebSocket code to use HTTP streaming. Option B, review the encryption requirements for WebSocket connections with the security team. Option C, meet with the cloud operations team and the engineer to discuss load balancer options. Option D, help the engineer redesign the application to use a distributed user session service that does not rely on WebSockets and HTTP sessions.
To arrive at the correct answer, we focus on the keywords, WebSockets and HTTP sessions, not distributed across the web servers.
The correct answer is option C, meet with the cloud operations team and the engineer to discuss load balancer options.
Why is this correct? C. GCP HTTP/S load balancing natively supports WebSockets and session affinity, sticky sessions. Discussing load balancer options allows configuration of session affinity so non-distributed HTTP sessions route to the correct backend server without requiring application redesign. Why are the others incorrect? A. Converting WebSocket code to HTTP streaming is unnecessary because GCP load balancing natively supports the WebSocket protocol. B. Reviewing encryption requirements with security does not address the application availability, WebSocket routing, or session persistence needs. D. Redesigning the application to eliminate WebSockets and stateful sessions is an expensive, unnecessary effort when GCP load balancers can handle sticky sessions natively.
The application reliability team at your company added a debug feature to their backend service to send all server events to Google Cloud Storage for eventual analysis. The event records are at least 50 kilobytes and at most 15 megabytes and are expected to peak at 3,000 events per second. You want to minimize data loss. Which process should you implement? The options are: Option A, append metadata to file body, compress individual files, name files with server name, timestamp, create a new bucket if bucket is older than 1 hour and save individual files to the new bucket. Otherwise, save files to existing bucket. Option B, batch every 10,000 events with a single manifest file for metadata, compress event files and manifest file into a single archive file, name files using server name. Event sequence, create a new bucket if bucket is older than 1 day and save the single archive file to the new bucket. Otherwise, save the single archive file to existing bucket. Option C, compress individual files, name files with server name, event sequence, save files to one bucket, set custom metadata headers for each object after saving. Option D, append metadata to file body, compress individual files, name files with a random prefix pattern, save files to one bucket.
To arrive at the correct answer, we focus on the keywords, send all server events to Google Cloud Storage, 3,000 events per second, minimize data loss.
The correct answer is option D, append metadata to file body, compress individual files, name files with a random prefix pattern, save files to one bucket.
Why is this correct? D. Appending metadata to the file body avoids extra API requests. Using a random prefix pattern distributes object key hashes evenly across cloud storage index partitions, preventing write hotspotting at 3000 requests per second and minimizing data loss from write throttle errors. Why are the others incorrect? A. Naming files with timestamps creates sequential object keys, causing partition hotspotting in cloud storage at high write rates, 3000 requests/SEC. Creating new hourly buckets is an unnecessary anti-pattern that fails to prevent key hotspotting within individual buckets. B. Sequential naming using event sequences causes cloud storage key hotspotting at 3000 writes per second. Batching events before writing increases latency and data loss risk if the batch buffer fails before uploading, while creating daily buckets provides no performance benefit. C. Sequential key naming leads to cloud storage index hotspotting during high write traffic. Updating metadata headers after saving requires a secondary API call for every object, doubling the API load to 6000 operations/second and increasing data loss risks.
A recent audit revealed that a new network was created in your GCP project. In this network, a GCE instance has an SSH port open to the world. You want to discover this network's origin. What should you do? The options are: Option A, search for Create VM entry in the Stackdriver alerting console. Option B, navigate to the activity page in the Home section. Set category to data access and search for Create VM entry. Option C, in the logging section of the console, specify GCE network as the logging section. Search for the Create Insert entry. Option D, connect to the GCE instance using project SSH keys. Identify previous logins in system logs, and match these with the project owner's list.
To arrive at the correct answer, we focus on the keywords: new network was created, discover this network's origin.
The correct answer is option C. In the logging section of the console, specify GCE network as the logging section. Search for the Create Insert entry.
Why is this correct? C. Cloud logging records admin activity audit logs for resource creations. Filtering by GCE network and searching for the insert operation entry allows you to identify the principle and origin of the network creation. Why are the others incorrect? A. The Stackdriver alerting console is used for managing metric-based alert policies, not for querying historical administrative audit logs to track resource creation. B. Resource creation is logged under admin activity audit logs rather than data access logs. Additionally, searching for Create VM inspects instance creation instead of network creation. D. System SSH logs inside the VM only record operating system login sessions, not GCP control plane infrastructure events such as network creation.
You want to make a copy of a production Linux virtual machine in the US Central Region. You want to manage and replace the copy easily if there are changes on the production virtual machine. You will deploy the copy as a new instance in a different project in the US East region. What steps must you take? The options are: Option A, use the Linux dd and netcat commands to copy and stream the root disk contents to a new virtual machine instance in the US East region. Option B, create a snapshot of the root disk and select the snapshot as the root disk when you create a new virtual machine instance in the US East region. Option C, create an image file from the root disk with Linux dd command. Create a new virtual machine instance in the US East region. Option D, create a snapshot of the root disk, create an image file in Google Cloud Storage from the snapshot, and create a new virtual machine instance in the US East region using the image file the root disk.
To arrive at the correct answer, we focus on the keywords: copy of a production Linux virtual machine, manage and replace the copy easily, different project in the US East region.
The correct answer is option D. Create a snapshot of the root disk, create an image file in Google Cloud Storage from the snapshot, and create a new virtual machine instance in the US East region using the image file the root disk.
Why is this correct? D. Creating a snapshot and converting it into a custom image stored in cloud storage enables seamless deployment across different projects and regions, providing an easily manageable artifact for instance replacements. Why are the others incorrect? A. Using Linux DD and Netcat is a manual, error-prone OS-level operation that risks data corruption and fails to leverage native Google Cloud image management. B. Standard persistent disk snapshots cannot be directly accessed across different Google Cloud projects to create new virtual machine instances without first creating a custom image. C. Using the Linux DD command requires complex manual steps and downtime, without creating an easily reusable or manageable GCP image artifact for cross-project deployment.
Your company runs several databases on a single MySQL instance. They need to take backups of a specific database at regular intervals. The backup activity needs to complete as quickly as possible and cannot be allowed to impact disk performance. How should you configure the storage? The options are: Option A, configure a cron job to use the cloud tool to take regular backups using persistent disk snapshots. Option B, mount a local SSD volume as the backup location. After the backup is complete, use CTL to move the backup to Google Cloud Storage. Option C, use XFiles to mount a Google Cloud Storage bucket as a volume directly on the instance and write backups to the mounted location using MySQLdump. Option D, mount additional persistent disk volumes onto each virtual machine (VM) instance in a RAID 10 array and use LVM to create snapshots to send to cloud storage.
To arrive at the correct answer, we focus on the keywords: backups of a specific database, complete as quickly as possible, cannot be allowed to impact disk performance.
The correct answer is option B, mount a local SSD volume as the backup location. After the backup is complete, use CTL to move the backup to Google Cloud Storage.
Why is this correct? B. Local SSDs offer ultra-high IOPS and throughput, enabling local backup files of a specific database to complete rapidly. Since local SSDs operate independently of persistent disks, backup write activity does not degrade primary storage performance. Why are the others incorrect? A. Persistent disk snapshots capture the entire disk volume rather than a specific database. Furthermore, snapshot creation consumes IOPS from the primary persistent disk, negatively impacting performance. C. XFuse relies on network file system translation, resulting in high latency and low throughput that slows down backups and can degrade database performance. D. LVM snapshots on persistent disk volumes share IOPS with the main database disk, degrading disk performance and adding unnecessary architectural complexity.
You are helping the QA team to roll out a new load testing tool to test the scalability of your primary cloud services that run on Google Compute Engine with Cloud Bigtable. Which 3 requirements should they include? Choose 3. The options are: Option A, ensure that the load tests validate the performance of Cloud Bigtable. Option B, create a separate Google Cloud project to use for the load testing environment. Option C, schedule the load testing tool to regularly run against the production environment. Option D, ensure all third-party systems your services use is capable of handling high load. Option E, instrument the production services to record every transaction for replay by the load testing tool. Option F, instrument the load testing tool and the target services with detailed logging and metrics collection.
To arrive at the correct answer, we focus on the keywords: load testing tool, Google Compute Engine with Cloud Bigtable. Choose 3.
The correct answers are option A, ensure that the load tests validate the performance of Cloud Bigtable, and option B, create a separate Google Cloud project to use for the load testing environment, and option F, instrument the load testing tool and the target services with detailed logging and metrics collection.
Why is this correct? A. Validating Cloud Bigtable performance ensures the underlying data layer scales efficiently alongside Compute Engine instances under peak synthetic workloads. B. Isolating the load testing environment within a separate Google Cloud project prevents synthetic traffic from disrupting production resources, quotas, and security boundaries. F. Detailed logging and metrics collection across both the load generator and target services supply the visibility needed to identify bottlenecks and analyze performance trends. Why are the others incorrect? C. Running heavy load tests against production risks disrupting rail and user traffic, degrading performance, and causing unintended service downtime. D. Third-party systems are outside internal management control, and bombarding them with load can violate service agreements or generate excessive third-party costs. E. Recording and replaying every production transaction creates major privacy, compliance, and storage overhead issues compared to using parameterized synthetic test suites.
Your customer is moving their corporate applications to Google Cloud Platform. The security team wants detailed visibility of all projects in the organization. You provision the Google Cloud Resource Manager and set up yourself as the org admin. What Google Cloud Identity and Access Management, Cloud IAM, roles should you give to the security team? The options are: Option A, Org Viewer, Project Owner. Option B, Org Viewer, Project Viewer. Option C, Org Admin, Project Browser. Option D, Project Owner, Network Admin.
To arrive at the correct answer, we focus on the keywords: security team, detailed visibility of all projects in the organization.
The correct answer is option B, Org Viewer, Project Viewer.
Why is this correct? B. Org Viewer permits viewing the organizational structure, while Project Viewer provides read-only access to inspect resources across all projects, giving the security team the required detailed visibility following the principle of least privilege. Why are the others incorrect? A. Project owner grants full administrative and modification permissions over projects, violating the principle of least privilege since the security team only requires visibility. C. Org admin provides full administrative control over the organization resources, while Project Browser only allows browsing the project hierarchy without granting access to detailed resource configurations. D. Project owner provides unnecessary write and administrative privileges, while network admin limits scope to networking configurations rather than granting organization-wide project visibility.
Your company places a high value on being responsive and meeting customer needs quickly. Their primary business objectives are release speed and agility. You want to reduce the chance of security errors being accidentally introduced. Which two actions can you take? Choose two. The options are: Option A, ensure every code check-in is peer-reviewed by a security SME. Option B, use source code security analyzers as part of the CI/CD pipeline. Option C, ensure you have stubs to unit test all interfaces between components. Option D, enable code signing and a trusted binary repository integrated with your CI/CD pipeline. Option E, run a vulnerability security scanner as part of your continuous integration/continuous delivery CI/CD pipeline.
To arrive at the correct answer, we focus on the keywords: release speed and agility, reduce the chance of security errors, choose two.
The correct answers are option B, use source code security analyzers as part of the CI/CD pipeline, and option E, run a vulnerability security scanner as part of your continuous integration/continuous delivery CI/CD pipeline.
Why is this correct? B. Integrating source code security analyzers into the CI/CD pipeline automates static code security analysis without introducing manual bottlenecks, maintaining release speed and agility while detecting security errors early. E. Running vulnerability security scanners automatically within the CI/CD pipeline checks for known security vulnerabilities rapidly during builds, ensuring continuous security validation while maintaining high release agility. Why are the others incorrect? A. Requiring a security SME to manually peer review every code check-in creates a severe operational bottleneck, directly violating the primary business objectives of release speed and agility. C. Unit test stubs verify component interfaces and functionality, but they do not specifically detect security vulnerabilities or reduce security errors. D. Code signing and trusted repositories ensure artifact integrity and supply chain provenance, but they do not analyze code to catch accidentally introduced security errors.
You want to enable your running Google Kubernetes Engine cluster to scale as demand for your application changes. What should you do? The options are: Option A, add additional nodes to your Kubernetes Engine cluster using the following command: Cloud Container Clusters resize cluster_name size 10. Option B, add a tag to the instances in the cluster with the following command: Cloud Compute Instances add tags instance tags enable autoscaling max nodes 10. Option C, update the existing Kubernetes Engine cluster with the following command: Cloud Alpha Container Clusters update mycluster enable autoscaling min nodes equals 1 max nodes equals 10. Option D, create a new Kubernetes Engine cluster with the following command: Cloud Alpha Container Clusters create mycluster enable autoscaling min nodes equals 1 max nodes equals 10 and redeploy your application.
To arrive at the correct answer, we focus on the keywords: running Google Kubernetes Engine cluster, scale as demand for your application changes.
The correct answer is option C, update the existing Kubernetes Engine cluster with the following command: Cloud Alpha Container Clusters update mycluster enable autoscaling min nodes equals 1 max nodes equals 10.
Why is this correct? C. Updating the existing running GKE cluster with Cloud Container Clusters update enables dynamic node autoscaling without needing to recreate the cluster or redeploy the application. Why are the others incorrect? A. Resizing the cluster manually sets a fixed node count instead of enabling automatic scaling based on changing demand. B. Adding compute instance tags using Cloud Compute Instances add tags does not enable or configure GKE cluster autoscaling. D. Creating a new cluster and redeploying applications causes unnecessary downtime because autoscaling can be directly enabled on an existing running cluster.
Your marketing department wants to send out a promotional email campaign. The development team wants to minimize direct operation management. They project a wide range of possible customer responses, from 100 to 500,000 click-through per day. The link leads to a simple website that explains the promotion and collects user information and preferences. Which infrastructure should you recommend? Choose 2. The options are: Option A, use Google App Engine to serve the website and Google Cloud Data Store to store user data. Option B, use a Google Container Engine cluster to serve the website and store data to persistent disk. Option C, use a managed instance group to serve the website and Google Cloud Bigtable to store user data. Option D, use a single compute engine virtual machine (VM) to host a web server, backend by Google Cloud SQL.
To arrive at the correct answer, we focus on the keywords: minimize direct operation management, wide range of possible customer responses, collects user information and preferences. Choose 2.
The correct answers are option A, use Google App Engine to serve the website and Google Cloud Data Store to store user data. And option C, use a managed instance group to serve the website and Google Cloud Bigtable to store user data.
Why is this correct? A. Google App Engine automatically scales web serving with minimal operational overhead, while Cloud Data Store provides fully managed, highly scalable NoSQL database storage for user preferences. C. Managed instance groups automatically scale web servers based on traffic demands, while Cloud Bigtable provides a managed NoSQL database built for high write throughput and massive scaling. Why are the others incorrect? B. Storing data on persistent disks prevents effective autoscaling and introduces significant operational management overhead for Kubernetes cluster administration. D. A single compute engine VM cannot autoscale to absorb high traffic surges and introduces a single point of failure.
Your company just finished a rapid lift and shift to Google Compute Engine for your compute needs. You have another 9 months to design and deploy a more cloud-native solution. Specifically, you want a system that is no-ops and auto-scaling. Which 2 compute products should you choose? Choose 2. The options are: Option A, Compute Engine with containers. Option B, Google Kubernetes Engine with containers. Option C, Google App Engine Standard Environment. Option D, Compute Engine with custom instance types. Option E, Compute Engine with managed instance groups.
To arrive at the correct answer, we focus on the keywords, Cloud Native Solution, NoOps and Autoscaling. Choose 2.
The correct answers are Option B, Google Kubernetes Engine with containers, and Option C, Google App Engine Standard Environment.
Why is this correct? B. Google Kubernetes Engine provides a cloud-native container orchestration platform with automated scaling and managed control plane infrastructure, reducing operational management overhead. C. Google App Engine Standard Environment offers a fully managed, serverless platform featuring automated scaling up and down to zero with zero operational management, NoOps. Why are the others incorrect? A. Running containers on Compute Engine VMs requires manual virtual machine management, OS patching, and infrastructure provisioning, failing the NoOps requirement. D. Custom instance types only adjust virtual machine CPU and memory allocation, still requiring full infrastructure and OS management. E. Managed instance groups enable autoscaling for Compute Engine VMs, but they still require managing VM templates, OS updates, and underlying infrastructure.